Algebra 2, Set 52, Chemical Mixture Problems. Okay, so these problems have to do with pouring mixtures of one substance, or actually of two different substances, into one large substance, and then there's a certain percentage each. Now, they have to do with an amount of water, and then in the water is an amount of chemical. So there's two parts to these problems. The first one is number, and that has to do with the water part of it. And then the second part of the problem is the value, and the value has to do with the percent of chemical that's in the water. So if you can think of the problem that way, that number is the water and value is like the percentage, just like those coin problems that we do, that have a number equation and a value equation, it's the same concept. So, for example, a druggist has one solution that is 10% iodine and another that is 50% iodine. How much of each should the druggist use to get 100 milliliters of a mixture that is 20% iodine? So again, you have a number and a value. When you have the number, you have the total, which is 100 milliliters. So we have the amount that you pour in plus the amount that you dump in is 100 milliliters. And basically you use two different variables just to kind of identify the two different solutions. And in the book they use P and D for pour and dump. It does not matter which one is which. So it's basically just P plus D is equal to 100. Now the next one is your percent one, or your value one. So we have 10%, 50%, and 20%. So 10% of what you pour plus 50% of what you dump is 20% of the whole. So in order to solve this, you just multiply everything by 10 to get rid of those decimals. So we end up with P plus 5D equals 200. And then if you notice the first equation, P plus D and P sub n plus D sub n equals 100, we can just put that right below, and then we can eliminate by subtracting. So 5D sub n minus D sub n is 4D sub n. 200 minus 100 is 100. Divide both sides by 4, and we get that the amount dumped is 25. So the amount dumped is 25, and I actually put it in the wrong place here, but it doesn't matter. 25 plus some value is 100, so we know the other one is 75. So we know that 25 of the 50% solution and 75 of the 10% solution is what was added. Let's do another example. A chemist has one solution that is 10% salt and 90% water, and another solution that is only 2% salt. How many milliliters of each should the chemist use to make 1400 milliliters of a solution that is 6% salt? So this problem has more information than you need. So you just need to pick out the information that you specifically need for this problem. You're going to have a number equation and a value equation. The number it's just what you pour plus what you dump is 1,400. That's the water. And then in the water, we're talking about the value, and we want to talk about the salt. So we've got salt underlined here. So 10% salt, and then that 90% we don't even need, because it's 10% salt, then it's 90% water. So that's extra information that you don't need. So 10% salt, so that's what you dump, and 2% salt is what you pour, and then the last 6% is the total. So 0.1D plus 0.02P equals 0.06 times 1400. To get rid of those decimals, multiply everything by 100, so you end up with 10D plus 2P equals 6 times 1400. And then we want to do elimination, so up above we'll multiply everything by 2, So you get 2D plus 2P equals 2,800, and now we can subtract. So we get 8D. Now 6 times 1,400 is 8,400. So 8,400 minus 2,800 is going to give you 5,600. So divide both sides by 8, you get 700. Now we can take that back and put it into our first equation, dump plus pour equals 1,400. And we know that the other amount has to be 700 also. So 700 milliliters of each solution is the answer.